I'm Anil Kumar, and here are a few more factoring questions from the test paper which I'd like to share with you. Now we'll try to understand how to solve such questions. Here are these questions. It is Unit Test 2, Equivalent Algebraic Expressions. I'm using 2A since this chapter has algebraic expressions in polynomials and rational functions. So we are considering polynomials at present. So here are four sets to be factored. The first one is 5x to the power of 4 minus 20x square y square plus 10x y cube. Then we have 32m square minus 64m minus 18, 4a square minus 100b square, and a variation of the second one where the center term has been changed to 48m. So I'd like you to pause the video, factor these trinomials or binomial in this case, right? And then check with my answer. Well, let's begin. The first one is 5x to the power of 4 minus 20x square y square plus 10x y cube. Now in this case we can do group factoring. 5 is common, so let's say 5. X is 1x is there in all. Y is not there in the first term, so we cannot take any y common. So 5x is the only common factor here. Dividing, we get x cubed from the first term, minus 20 divided by 5 is 4, x square, x is common, so x, and y square. From the third term, 10 divided by 5 is 2, x has been factored out, we're left with y cubed. So that is how we can factor it. Now let us factor the second one, which is 32 m square 64m minus 18. Now all are even numbers. You can factor out 2. 32 is not divisible by 3, so we cannot factor any other number. 2 is a common factor. So we can write this as 2 within bracket we get 16m square minus 32m minus 9. And let's explore whether we can factor this further or not. Well, 9 seems to be a 3 square and 16 is 4 square. Center term, is it 2 times 3 and 4? 3 times 4 is 12 and 2 times 12 is 24, not 32. So it cannot be further factored. So that is how we have to leave it. So let me jump to a variation to this question now, which is right there. So at times in test paper, which was in this particular case, you are given a trinomial which cannot be further factored. Now students may spend a lot of time working out, but it may not work out, but may waste a lot of time. So be careful about it. So here's a variation which can be factored. So let me do that one. So we'll again take 2 common. So in this case we get 16m square minus 24m minus 9 when I take away 2 common, correct? Now this is a perfect square. We could write 16 as 4m whole square, right? So just to explain you, 16 is, or let me write like this, 2 times, I could write this as 4m whole square, and I could write this as, well, this is negative. If it was positive, then it could have been factored. Let me make it positive now. Okay, so I'm making it positive, changing the question once again so that it could be factored, right? The whole idea is at times we may have such a situation, right? So that could be written as plus 3 square. The center term is 2 times 3 times 4m. 2 times 3 is 6, 6 times 4 is 24m, right? So have a good look at it. In test we can have all variations of this question, right? So we have 2 times 4m minus 3 whole square. That is only the case if we have a trinomial which is plus 18, center term minus 48m, and the first term 32m square. In all other variations this could not be factored, right? So be careful about it, okay? Now let's see the one which I left here, which is difference of squares, right? You could write this as 2a whole square, this as 10b whole square, and factor it. That is one way of doing it. The other way is you can factor 4, correct? So if I factor 4, what am I left with? I'm left with a square minus 25b square, right? Now 25b square is like 5 square, correct? Therefore I can write this as a plus 5b times a minus 5b. So that is how I can factor this, right? Remember, this is a square and here we have 5b whole square, right? So it is difference of squares. So whenever you have a square minus b square, it could be factored as a plus b times a minus b. So that is what we utilized here. I hope that helps to understand. So in a test paper, it is not necessary that you may have questions which will be factored to very simpler terms, right? You could have group factoring as we have here, right? So those could be sometimes tricky questions where you may spend unnecessarily an extra time to figuring out how to factor them further, right? So it comes with practice. I hope that helps. If this question is changed a bit like this, it could be factored. Otherwise, that was your answer, right? Okay, I hope that helps. Thank you and all the best.